Hi all, hope you all are doing extremely well. So today in this video we are going to solve bi-weekly contest 70 problems, right, of LeetCode platform. So in this video we'll be solving two initial problems of the contest and later on we'll be covering the remaining two. So the first one is minimum cost of buying candies with discount and another one is count the hidden sequences, right? So we are going to have a look on these two problems. First of all, we'll be understanding the problem statement and then the logic part, and then we'll be moving to the coding solution, right? So make sure to watch the complete video. But before proceeding further to the video, if you are new to this channel or if you haven't subscribed our channel till now, then guys do consider subscribing our channel. It will really motivate me to make more such content for you, and definitely the channel will be helpful. So do consider subscribing our channel and do join the Telegram community as well. So let's discuss our first problem now. So the problem says a shop is selling candies at a discount. For every two candies sold, the shop gives a third candy for free. The customer can choose any candy to take away for free as long as the cost of the chosen candy is less than or equal to the minimum cost of the two candies bought. So it's like the discount you will be getting only if you have bought two candies. And another scenario is that you can choose any candy to take away. It's your choice. The condition that is implemented, that the cost of the chosen candy is should be less than or equal to the minimum cost of the two candies that has been bought, right? So for example, if there are four candies with cost 1, 2, 3 and 4, and the customer buys candies with cost 2 and 3, right? So what is like in this case, what you can see, the minimum cost is what? The first one price is 2 and another one is 3. Minimum is 2. So you can choose any candy. The condition is that the candy that you are choosing, its cost should be lesser than or equal to the minimum cost, which is nothing but 2 in this case. So we can choose what? We can choose the candy with cost 1 for free, but not the candy 4 because the price is greater, like for this one, right? So we can choose 1. So given a 0 index integer array cost, where cost I denotes the cost of the ith candy, we have to return the minimum cost of buying all all the candies, right? So let's understand the approach now, that how we'll be solving this problem. Okay, so but before proceeding further, let's have a look on the example as well. So as you can see for this one, so what we can do is, see, you have to buy two candies, only then this discount is applicable. So here, if we buy these two candies of cost 2 and 3, so what we can do is the minimum is going to be 2, and hence we can take a candy of cost 1 as free, right? Because its cost is smaller than that of the minimum, which is in this case is 2. So 1 is obviously lesser than that of 2, right? So what will be the overall cost or minimum cost? 5. 5 you have to invest. So that's what we are getting in the output. In this case, if you will check, so we are getting output as 23. How? So what we can do is buy the candies with cost 9 and 7. So what you can do is you can take the candy whose cost is 6 as free, because in this case you will see what is the minimum cost, 7, and obviously 6 is lesser than that of 7, lesser than equal to, like this was given na, less than or equal to. Okay, so 6 is obviously lesser than that of 7. Okay, so you can take the candy of cost 6 as free. Now buy candies with cost 5 and 2. So what you can do is you can take the last remaining candy which is of size which is of cost 2 for free, right? So the minimum cost that you have to invest is to buy all candies. It is 9 plus 7 plus 5 plus 2, that is 23. And in this case there are only two candies. So if there is only two candies, then obviously you have to pay for both of them. So hence we are getting 10 as the output. We buy both of them and there's a no third candy we can take for free. Hence the minimum cost to buy all candies is 5 plus 5, that is equal to 10, right? So this is how it is. So while solving this problem, so some boundary cases that you can handle is that if let's say the size of the given array is just equal to 1, so simply return that one element that is present in the array. If it is 2, then simply return the sum, the addition of the two elements that you have in the array, because you know, like we need 3 candies at least to handle our scenario, right? So now if there are 3 candies, let's say 1, 2, 3, these were the candies that we were having now. So what we can do is take the summation of the last two, and this one, the price of this one is not going to be included, and hence the summation that is going to be 5, and that's what we have to invest. Let me take another example so that you can get a proper understanding. Let's take, we have 2, 2, 5, 6, 7, 9. So one thing to observe is that how we are making sure कि ठीक है, like as if in this particular case, see the example that we were having, the test case that we were having, that was not sorted, right? So the first thing when you were going through the examples itself, that must be a kind of bell that must be ringing in your mind, is that first thing that we have to do is we have to sort our array, right? Because you must be getting that when we are choosing the element, we are choosing the larger one. Like when I was explaining the example, so here in this particular test case we were taking 9 and 7. So first thing that we have to do is we have to sort our array. So let's consider I have taken the same test case. So after sorting, this is the array that you are supposed to get. So we have sort our array. Now what we are doing is, now you know that we have to choose two candies. So from the last we have chosen these two candies. Now you know that the candy before it we can get in free. That's for sure, because our array is what, sorted. So we are able to get it free, so we are not going to consider this in our cost. Then later on, you know that these two candies price we have to consider, these two candies cost we have to consider, and the candy before it, this cost, the cost of this one we can ignore, right? So simply, like what we can do is we can take a loop, and I equal to n minus 1, I greater than equal to 0, I minus equal to 2. Now see these two elements, we'll be considering at 1, that's why I am doing I minus equal to 2. Now so what we'll be doing is we'll be adding the ith element, that is here, let's say array is a, okay, so a of I, fine. Now you'll be saying, okay, let's add here a of I minus 1 as well, right? So this is added, this is also added. Now you know that this one element is also we are not going to consider, so we have to reduce our I value one more time. That's what also we are supposed to do. So if you will go through this loop, see what we'll be having. So element at ith position as of now is 9. Let me put the indexing as well, 0, 1, 2, 3, 4, 5. So a of 9 and a of 5 and a of 4, if you are going to add them, you will be getting 16. And this one candy we are going to get in free, so we are not going to include the cost of that. So that's why I value we are further reducing. See, we are doing I minus equal to 2. It means 5 minus 2, 3, and one more reduction is there. So 3 minus 1, that is 2. So our I value is 2 now. Again, what we're going to do is we are going to take a of I, that is 5, and a of I minus 1, that is 2, right? So what you'll be getting is 7. So 16 plus 7, you will be having 23. And further I minus we are doing, so I value will be, so I value was what in this case, that was 2. So 2 minus 2 is already 0, and one more reduction has been also involved here. Like this one will become first and then this one. You must be knowing the flow, right? So I value will move to the negative part, right? So this will work fine. But if I'm taking this particular test case, let's say 2, 2, 2, 5, 6, 7, 9, right? So we have sorted our array. Have this in mind, we have sorted our array. Now these two pair will be considered, and this is going to be ignored. These two, this is going to be ignored, right? Now if we will write like this, then a of I we do have, that is 2, right? But a of I minus 1 is missing now, so we cannot write like this directly. We can put a if condition here, simply that if I value is greater than equal to 1, right? If I value is 0, obviously there won't be any I minus 1 that would be existing, and obviously some error will be there. So make sure that if I value is greater than equal to 1, only then we are adding this a of I minus 1 to our s value. S you can say is sum or something, right? And at the last we'll be returning this s. That will be having the minimum cost that we have to invest to buy the candies. So you must have understood the approach now. Okay, so let's move to the code part now. So you can see that's the approach that we just discussed. We are just implementing the same. So if n value is 1, simply return cost of 0. If n value is 2, simply return cost of 0 plus cost of 1. Otherwise, we are sorting our array. Now we are having this variable s initialized with 0. So we are taking a loop. We are adding the ith element to s. We are adding I minus 1 after making sure that I value is greater than or equal to 1. So you can see here we are doing the reduction of I minus equal to 2, and here also we are doing I minus minus. The approach that we just discussed, we have just written the code for the same, and at the last we are returning the s, right? So I hope that you must have understood the approach and the code part as well. So let's jump to our next problem, right? So this was kind of mathematical based, we can say something like this. So let's understand the problem now. The problem says you are given a zero indexed array of n integers differences, which describes the differences between each pair of consecutive integer of a hidden sequence of length n plus 1. More formally, call the hidden sequence hidden when we have that differences I equal to hidden I plus 1 minus hidden I. You are further given two integers lower and upper that describe the inclusive range of values lower upper that the hidden sequence can contain. For example, given differences equal to 1 comma minus 3 comma 4 lower equal to 1 upper equal to 6, the hidden sequence is a sequence of length 4 whose elements are in between 1 and 6 inclusive. So these ranges are also included. So what is the possibility for the given scenario? 3 4 1 5 we can have, this can be our hidden array, and 4 5 2 6, right, are the possible hidden sequences. These two are not possible because you can see we are having an element that is greater than 6 here, that is here that we have 7, and is not possible since the differences, and here in this case the differences are not correct, right? I'll be explaining you the approach in case you are not understand the problem statement. We'll be having a proper look on that, so don't worry. As of now, I'm just reading the statement that is given, right? So let's take a scenario and let me explain you that what is problem is actually trying to explain, and then the probably will be moving to the approach part, right? So according to the given problem, we are having a differences array. Let's say we are having 1 minus 2 comma 4. Now, so for this we have to, for this particular array, we have to find out the hidden sequences that are possible, or hidden arrays that are possible, that we can say. Now, how we'll be determining that hidden sequence? So they have said that the diff of, let me call this array as diff. So diff of I is calculated as hidden of I plus 1 minus hidden of I. So we have to find out that hidden particular array. Now for this given array, now we have to determine how many hidden sequences are possible. That's what our task is. Also, they have provided some range as well, upper as well as lower. So whatever elements that we are going to consider for our hidden sequence, we have to make sure that the element should be greater than equal to the lower range that is given. Let's say for this particular scenario, let's say lower value is 1. So we can take the elements that should be greater than equal to 1, and for upper, let's say we have 7. So the elements should be lesser than equal to 7, right? So what are the possibilities? If you will see for this particular scenario that is given, we can have 2 3 1 5, right? Now how we can say so? So let's say we are having this particular hidden sequence. So diff of I, how we are determining? Hidden of I plus 1 minus hidden of I. This is the diff array given to us. I plus 1 is what? 3. 3 minus 2, you will be getting 1. Then 1 minus 3, you will be getting minus 2. Then 5 minus 1, you will be getting 4. Other possible sequences are, we can have 3, 4, 2, 6. We can have 4, 5, 3, 7. So for this particular test case, only 3 sequences are possible. Let me take these as well. So 3, 4, 2, 6. 4 minus 3, you will be getting 1. 2 minus 4, you will be getting minus 2. 6 minus 2, you will be getting 4. 4, if I am taking, if I am taking 4, 5, 4, 5, 3, 7. So 5 minus 1 will be giving you, 5 minus 4 will be giving you 1. 3 minus 5 minus 2. 7 minus 3 will be giving you 4. So these are the possible sequences, hence the count is what? 3. So for this particular test case, 3 will be our answer. So some kind of observation thing is there that we have to see. So for this particular test case, we have to find out a value. If you want this particular diff array, what can be the possibilities? Let's say we are having a number x, right? Now the next number, see for this one, what will, you can see what is the length, what is the number of elements that we do have in our hidden array? 4, right? So how we can make a scenario for the same? So let's say we are having a number x. The later number should be in such a manner so that on doing I plus 1 minus ith element, we can get 1. So what we can take is x plus 1, because x plus 1 minus x will be giving you what? 1. The next element what you can take is x minus 1. How I can say so? Because x minus 1 minus x plus 1. So this would be cancelled, and minus 1 will be giving you minus 2, and that's what we need here. The next element that we can take is x plus 3. How I can say so? So x plus 3 minus x minus 1, that will be giving you x plus 3 minus x plus 1. So 4, and that's what we need here, right? So this kind of, now we have to look for the x values. So what will be the minimum value if you will check out for this particular sequence of this the kind of derivation that we have done? Minimum value will be x minus 1. See, here we have to figure out the minimum and maximum value, because we have to take care of the lower and upper range that has been given to us. So x minus 1 is the minimum value. So we have to make sure what? That x minus 1 value should be greater than equal to the lower range that is given to us, that is nothing but 1. What is the maximum value here? X plus 3. We have to make sure that x plus 3, that is the maximum value, that should be lesser than equal to upper range, upper value, that is 7. So if you will be solving it, x minus 1 greater than equal to 1, x plus 3 less than equal to 7. So you will be getting x value should be greater than equal to 2, and x value should be lesser than equal to 4. So we can choose the element in this particular range. So what are the element in this particular range? 2, 3, 4. So x value should be lying from these particular elements. 2, 3, 4 we can choose, and that's what we have done here for these sequences, right? If you will put these value 2, 3, 4, you will be getting these 3 sequences, hidden sequences, right? So now you must have understood the approach, that basically what we are trying to do. So if the approach part is clear, then probably we can move to the coding part, and you will be getting a better understanding for the same. So here's the code for the approach that I just discussed. So what we are doing here is, we have maintained 3 variables, max, min and sum. So max and min variables are responsible for having the minimum value and the maximum value. So how we are calculating that? So what we are doing is, we are having a for loop here, right, moving till the length of the given array. So what we are doing is, one by one, let's say for our case what we were having is 1 minus ka 2 and then 4. So we are determining the minimum and max value that we can get. So some value, if you will move inside this, some value is going to be 1. So min will remain as it is, that is 0, because in this we are storing the minimum value. Max value will be updated to what? Let me write here. Min value will remain 0. Max will be updated to 1. Then further will be moving to next element, that is minus 2. So some value is going to be what? That is already 1 now. Sum is already 1. So minus 2 plus 1 will be having minus 1. So min value will be updated to minus 1 this time, and max value will remain as it is. Now sum value is minus 1. We'll be moving to the next element. So 4 minus 1 will be having 3. So min value will remain as it is, that is minus 1 itself, and max value will be updated to what? Max value will be updated to 3, right? So this is the min and max value that we have got. Now we have to check for the range. So our value is given in our scenario, that was 7. So 7 minus max value is 3. We'll be having 4. And lower value in our scenario is given as 1. And min that we have got is what? Minus ka 1. So 1 minus ka 1. You will be having what? So this is the range that we have got. Minimum is, that is 2 se leke 4 tak. 2 to 4. This is the range that we have got. So how many possible sequences will be there? Obviously 2 minus 4 plus 1, right? So 3 sequences were possible. We discussed now when we were discussing the approach. So there can be a scenario that this kind of, like, we are not able to obtain the hidden sequence, like as for this particular test case. So we have to check. Simply we are checking here that if res minus res2 plus 1, if it is greater than 0, then we are returning this value only. Otherwise, there's not a possibility, so we are returning 0. If it is not greater than 0, so we are simply returning 0. That will be happening in this particular test case. In case still there is some confusion, so I would suggest you to dry run the code, take a copy pen, try to understand. Probably you will be understanding, right? So these are the initial two problems. We'll be discussing more. So make sure to subscribe our channel if you haven't subscribed till now. Thank you for watching this video, guys. Keep learning, keep coding. Bye bye.